Multiplying polynomials, Algebra 2 Common Core. So this is the first video of the year. This is Unit 1, Section 1. So welcome back to school. I'm sure you're thrilled. And this is an algebra course. You most likely took a geometry course last year where you learned a lot of problem-solving techniques and things that are hopefully going to help you in this course. But it's not as much about polygon properties and things like that. It's way more algebra-based. That's why it's called an algebra course. And you see that with what we're starting out with here of just multiplying polynomials. Now, this really should be a review from Algebra 1. There's nothing in this video and in this first lesson that you didn't do in Algebra 1 and probably a little bit in geometry too, but it's just kind of a way to knock off the algebra rust from the summer and from geometry to see if you remember how to distribute or do a binomial squared and combine like terms. What happens when you multiply things with exponents? Do you add them? Do you multiply? All that stuff's going to come up here. And we'll do a little practice, but if this is your first time watching one of my videos, you're encouraged to pause it at any time if you need it to be paused, or rewind, and try to take detailed notes. You'll see me take down notes here. Take down those notes along with me on this worksheet that you should have. And if you have a 4-colored pen, which I recommend, then you can use the colors that I do. And if you find yourself having questions, please remember, write that question down somewhere on this piece of paper. So when you come into class tomorrow, you remember what your question was and you could ask that question. Because that will happen, and I want you to ask those questions. So don't forget to write them down as you have them. So this is an example section right here. So there's nothing for you to really do here. I'm just going to kind of read it to you. But it's talking about multiplication of polynomials, and it's really a form of distribution. Each term from one polynomial gets distributed to each term of the other polynomial, each with each. And then combine like terms and write an exponential descending order. So if I want to multiply this trinomial of x squared plus 5x minus 2 times this binomial of x plus 3. The x squared term has to get multiplied by the, how did we do this here? Yeah, the x plus 3 times each of these things. So x squared gets multiplied by x plus 3. 5x gets multiplied by x plus 3. Negative 2 gets multiplied by x plus 3. And you can think about distribution within each of these. Now, there's a couple of different ways to think about the distribution that you do along here. By the way, I just erased ink to kind of so you can see better. You don't have to erase the ink. I'm going to actually go to a thinner pen right now to help me write a little bit better. It's better. But one option is to do like a box method, or called the tabular method. I'll show you that in another example on the next page. But everything from this has to get multiplied with everything from there. X squared gets multiplied by both of these, and 5x both these, so on, so on, so on. But you could also think of it, the other way. I could think that, all right, I got to multiply x by this, this, and this. And then I multiply 3 by this, this, and this. And one thing to point out is that there's 3 terms here and 2 terms here. So that means we should end up with a total of 6 terms after multiplication. 1, 2, 3, 4, 5, 6. And then you combine like terms, and it usually ends up being less. In this case, we ended up with 4 terms. One thing here, notice that when we multiply x squared times x to the first, we get x to the third. When you multiply common base, you add the exponents. We're going to have an entire chapter dedicated to exponents. So this is just basic stuff for now. One of the things we have to do, not just multiplying 2 things together, but something to itself, a polynomial squared, specifically a binomial squared. And that just means times itself. And you can split it and write it twice as times itself if you like doing distribution that way. There is a binomial squared shortcut, and that's what I'm showing you here, that for a plus b squared, it's the first term squared, the last term squared. That gets you the 2 ends. The middle comes from these things times each other doubled. So times each other doubled. That's how you get the middle piece. And you see that here with x squared minus 25. Square the front, we get x squared. Square the back, we get positive 25. Negative 5 times negative 5 is positive 25. Times each other would be negative 5x, but you double it to be negative 10x. Because in the distribution, you would see that you would end up with it twice. So it's just kind of a shortcut that comes up a lot. So it's really a helpful thing to know how to do. You're going to have to see that a lot this year. All right, so let me do some practice problems from the beginning for you. Here, this is just simple distribution. It's not actually two polynomials. This would be a monomial times a polynomial. But it all stems from distribution. So what is 2x squared times 5x cubed? I multiply the front, 2 times 5 to get 10. And then the variables, I add the exponents, 2 plus 3 to get 5. When I multiply a common base, I add the exponents. 2x squared times negative 3x to the first would be negative 6x cubed. And it's my hope that you could probably do this entire worksheet without me showing you how to do a video. Like I said, this should be completely review for you. But in case you don't, like I said, just knock off some rust and maybe you'll learn some tricks that you didn't learn from your previous algebra teachers. All right, here we got a binomial times a binomial. So if we do distribution here, so I got to go back into my settings and make all my pens thin again this year. I'm going to multiply x times x and x times negative 3. X times x is x squared. X times negative 3 is negative 3x. Then I'll do 5 times x to get a positive 5x. 5 times negative 3 to get negative 15. Of course, you have to know your basic principles of when I multiply a positive times a negative, it's negative and things like that. At this level, you're expected to be able to do this fairly easily. These are my like terms because they have the same variable with the same exponent. So negative 3x and 5x combines to be a positive 2x, negative 3 plus 5, and a negative 15. And now there's no more like terms here. These both have an x, but they have different exponents, so they're not like terms. And so that's the final answer there. One more example here, and this one's a little bit of a challenge. So let me get some space here. You see that it is a binomial squared right here. Go with thin marker, go to blue. Is a binomial squared times a trinomial. Now, the order of operation tells us we need to do anything like exponent stuff before we multiply. So we actually need to do this binomial squared first and then multiply it by that. So if we just take the x squared, x plus 4 squared piece, and let's multiply that out. And the shortcut there is I'm going to square the first term. The middle comes from times each other doubled. So times each other is 4x, double it to 8x. And then squaring the back is 16. Once you really get good at that shortcut, it becomes very easy. And like I said, it's going to really save you time in this course, and it actually makes those problems easier in the end. You don't have to do that shortcut. You could always write it as, x plus 4 times x plus 4 and multiply or draw a box. There are other options, but it is just a nice shortcut that if you can master that, it's going to make this year a lot easier for you. All right, here I have a trinomial times a trinomial. Anytime it involves trinomial to a trinomial, I actually do like to do what's called the tabular method. And the tabular method is basically, some call it the box method. What I do is I have to take one of the terms, x squared plus 8x plus 16, and write it on top of a box. And then to the left of the box, I write the other polynomial, x squared minus 2x plus 1, like that. And what I'm going to do is I'm going to turn this into kind of like a multiplication table type of thing. And so I'm going to have, rows and columns. And I'm going to multiply everything with everything, but it's kind of helpful to do this in a table when it gets big. Now, when it's small stuff like binomial times binomial or distribution, I think this is overkill. But if you like this method, you could do this for all the multiplications that you see. And so now I see for this box, it's x squared times x squared, and that's x to the 4th. And I usually either go like down or I go over. I wouldn't just like randomly do them. So like this column here is x squared times the 3 pieces of this polynomial. So x squared times that is x to the 4th. X squared times negative 2x is negative 2x cubed. X squared times 1 is x squared. Then this column, 8x times x squared is 8x cubed. 8x times negative 2x is negative 16x. 8x times 1 is 8x. 16 times x squared is 16x squared. 16 times negative 2x is negative 32x. And 16 times 1 is 16. Now, one cool feature about this, especially when you do this, is it kind of checks your work for you a little bit. Notice that there's only one x to the fourth term, and there's only one constant, 16. That's a term without a variable. But there are multiple x to the cube terms, there's multiple x squared terms, there's multiple x to the first terms. They are set up in diagonals, that these should be like terms, and they are. They both have x cubed. These should be like terms. And this is x squared, this is x squared, but this one wasn't squared. So what that tells me is I made a mistake. So I can go back because I recognize that that diagonal isn't like terms. I did something wrong. And looking back at that, I am going to catch my mistake. The negative 2x times 8x is negative 16x squared. So it is a helpful way to kind of check your work. That's going to be by itself. Those are like terms. Those are like terms. Those are like terms. That's by itself. And then when I'm combining like terms, it's kind of organized for me. That when it's in like a long chain like we see on this page, sometimes you have to kind of go through it and say, all right, that goes with where else are there x squared terms, kind of stuff like that. Which, again, you can do that, but when it's in the box and they are organized for you, it does kind of help you, just do the problem a little easier. I don't think you need to do this box when it's binomials or just distribution, but when it's trinomials and bigger, I do think it helps. So x to the fourth, then combining these, I have a negative 2 and a positive 8. That's a positive 6x cubed. And we always list these in exponent descending order. So my highest exponent down to my constant without anything. And the highest exponent means it's called the degree of the polynomial. So this is a degree 4 polynomial. Then I got like terms here. Remember, there's a 1 when you don't see a number in front of a variable. So it's 1, negative 16, 16. Those cancel out. So it is just a 1x squared. And you could always write the 1. It's optional. Just like these exponents. You could write x to the first. It's optional. Negative 32 and 8 is going to be a negative 24x. Right? Of course, you could use calculator, check your math. I'm just kind of doing this mental. Would be nice. Yeah, that works out. And then the 16 is going to be plus 16. And that's my final answer there. So this is called the tabular or box method, and it is a helpful way to do some of the more advanced multiplication you're going to have to do. So they recommend the binomial squared pattern. That's going to help you there. But always just, it's distribution, it's multiplication, it's math you've been doing for years. All right, guys, so that's your first video for Algebra 2 Common Core. It's running about 12 minutes and change here. I usually like to keep it under 10, 11, but I kind of talked a little bit about the course in the beginning. That's what slowed us down. So most of the videos will probably be a little bit shorter than this one. So have a great day, and I'll see you later.